Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. So today we're going to be reviewing for the Chapter 9 test, which is tomorrow. So tomorrow during class time, there will be no regular Zoom meeting. So if you come looking, you'll be alone. Anyway, we have a lot of questions that people emailed me. So I want to go ahead and get started. Okay. This is from section 9.5, number 17. It says, solve the equation, enter your answers as a comma-separated list. That is, if there's more than one answer. Okay, so the original equation is this. The square root of the quantity 6 minus 2x equals 2 times the square root of the quantity x minus 3. So we have an equation with two radical terms, and they are separated, one on each side of the equal sign. We're going to square both sides. On the left side, we get 6 minus 2x. On the right side, that squared is going to apply to the 2, so that's a 4, and then it's also going to apply to the radical, so we're going to get x minus 3. Any questions on that step? All right, so we get 6 minus 2x equals, distributing 4x minus 12. I'm going to solve for x on the right. So I'm going to add 2x to both sides of the equation. 6 equals 6x minus 12. I'm going to add 12 to both sides of the equation. 18 equals 6x. Divide both sides by 6, and I get x equals 3. Let's check that answer. So let's see here. We'd have the square root of 6 minus 2 times 3 equals 2 times the square root of 3 minus 3, which would be the square root of 6 minus 6, or the square root of 0, or 0 on the left, equals 2 times the square root of 0 equals, 2 times 0 equals 0, 0 equals 0. So x equals 3 is the only solution, and it works. Any comments before we go on to the next one? All right, this is 9.5, number 21. It says, solve the equation for the indicated variable. The equation is r equals the cube root of the fraction a divided by p, and then minus 9 as a separate term, and we are to solve for p. We have an equation with one radical, but it's not all by itself. So the first thing I'm going to do is add 9 to both sides of the equation, which gives me r plus 9 equals the cube root of the quantity a divided by p. The next thing I'm going to do is cube both sides. So I get r plus 9, the quantity cubed, equals a over p. We're solving for p. So then I'm going to multiply both sides by p. So I get p times the quantity r plus 9 cubed equals a. But then I'm going to divide both sides by r plus 9 cubed. So p equals a divided by r plus 9 cubed. And the person who did this, you had a times the quantity r plus 9 to the third power. So you were close, but just that last step perhaps. Okay, that's 21. We're moving on to number 24. We good to go on? Okay. 9.5, number 24. This says, solve the equation, write all proposed solutions, If a solution is extraneous, so indicate. All right, so we've got negative s minus 3 equals 2 times the square root of 5 minus s. We have one radical. It's already isolated, so I'm going to square both sides of the equation. On the left side, I get negative s minus 3 times negative s minus 3. On the right side, I get 2 squared times 5 minus s. Again, this gets applied here as well as there. Okay. Now, on the left side, continuing foiling, I get s squared plus 3s plus 3s plus 9 equals 4 times the quantity 5 minus s. Combining like terms on the left side of the equation, I get s squared plus 6s plus 9. Distributing equals 20 minus 4s. This is a second degree equation. I see that from the term s squared. I'm going to put everything on the left side of the equation. So I'm going to subtract 20 from both sides of the equation and add 4s to both sides of the equation, which gives me s squared plus 10s minus 11 equals 0. Okay, now let's see if we can factor the left side of the equation. We'd have s and s plus 11 and minus 1. That would give me 10s in the middle and a product of negative 11. So we get s equals negative 11, s equals 1. So those are the two proposed solutions, okay? And it says to write the smaller value first. So s equals negative 11 would be the first answer. S equals 1 would be the second answer. But then we're supposed to go back and see if they work or not. Okay, so let's start off with the negative 11. If s is negative 11, we get, let's see here, negative times negative 11 minus 3 equals 2 times the square root of 5 minus negative 11. Can you see that, or am I off the screen there?
Looks good.
Okay.
Yeah, we can see it.
Okay, so this is 11 minus 3, or 8, equals 2 times the square root of 16, 2 times 4, 8 equals 8. So this one is not extraneous, meaning it works, okay? Then let's take the 1 and the s equals 1 and try that. Let's see, that would be negative 1 minus 3 equals 2 times the square root of 5 minus 1. Negative 4 equals 2 times the square root of 4. Negative 4 equals 2 times 2. Negative 4 equals 4. So this one is extraneous. So our two solutions, negative 11 and 1. Negative 11 is not extraneous, meaning it works, and 1 is extraneous, meaning it does not work. Any questions about that problem? Okay. That takes us to the chapter review from this person, number 9. Sorry, things are moving slowly here. Number 9. Okay. So this is the chapter review number 9. And it says, simplify the expression, assume that the variable is unrestricted, and use absolute value symbols when necessary. Okay. So that means the variable could be positive, negative, or 0. We can't assume anything. So here is our original expression that factors into 2 identical factors. It's a perfect square. So then I get x plus 5. However, I don't know whether x is positive or negative or 0. Since it's said they're unrestricted, since we're taking an even root, we can't get a negative answer. Therefore, we need absolute value bars. So that was the missing piece on that problem. Okay, let's go on to the next person here. And give me a minute to get their stuff up here. Let's see. This 9.5. Okay, so this, we're back to section 9.5, and this is number 14 coming up. Okay. It says, solve the equation, enter your answers as a comma-separated list. Okay. We have the cube root of b cubed minus 117 equals b minus 3. So we've got our radical isolated. It's a cube root, so we're going to cube both sides. On the left side, I'm going to get b cubed minus 117. On the right side, I'm going to get b minus 3 times b minus 3 times b minus 3. Okay, 3 factors. I'm going to multiply the first 2 first, which is b squared minus 3b minus 3b plus 9. All that times b minus 3, the third factor. Combining like terms, b squared minus 6b plus 9 times b minus 3. Okay. Distributing, I'm going to get b cubed minus 3b squared minus 6b squared plus 18b plus 9b minus 27, which is b cubed minus 9b squared plus 27b minus 27. And I'm going to bring this down here. So there is our equation multiplied out. Let's see here. I just want to make sure I didn't make any mistakes. I think it looks good. All right. I'm going to subtract b cubed from both sides and get negative 117 equals negative 9b squared plus 27b minus 27. I'm going to add 117 to both sides, which gives me, I'm going to go to the next page, negative 9. Wait a second here. What have I written? Negative 9b squared. Got too many b's there. I could get stung with all those b's. All right, 9b squared. Is that correct now? Yes. So negative 9b squared plus 27b. And let's see. That would be what? Plus 90? Plus 90 equals 0. Okay, so I get 0 equals negative 9b squared plus 27b plus 90. All right. I could factor out a negative 9, and I get b squared minus 3b minus 10 equals 0, which is -9 times b minus 5 plus 2. So I get b equals 5, b equals -2. And those are the two solutions. Any questions there?
No.
All right, let's see here. That takes us to number 15. So this is 9.5, number 15. Solve the equation, enter your answers as a comma-separated list. And this is very much like the previous one. In fact, it's almost exactly like it. We have x cubed plus 37 to the 1/3 power equals x plus 1. So instead of it being a cube root, it's a 1/3 power, which is basically the same thing. So we're going to cube both sides. On the left side, we get x cubed plus 37. On the right side, we get x plus 1 times x plus 1 times x plus 1. Doing the first two, we get x squared plus x plus 1 times x plus 1, which is x squared plus 2x plus 1 times x plus 1, which is x cubed plus x squared plus 2x squared plus 2x plus x plus 1, which is x cubed plus 3x squared plus 3x plus 1. Bring this down, and we have that. Any questions so far? I know I went through those calculations kind of quickly. I'm going to subtract x cubed from both sides, and I'm going to subtract 37 from both sides, and I get 0 equals 3x squared plus 3x minus 36. Oh, I can factor a 3 out, and I get that. And then I get, let's see, 0 equals 3 times, and that's going to be, that's what, a 12, so it's going to be a plus 4 and a minus 3. So x is -4, x is 3. And there's the two solutions. Any questions there before we go on?
No.
Okay. Still in section 9.5, here is number 24. Let's see, I'm going to try and get through all of these, but I don't want to go too fast and make mistakes and all that good stuff. It says solve the equation, write all proposed solutions. If a solution is extraneous, so indicate. So we did one like this earlier, but this one I believe has different numbers. If I do one that I've already done the same, please let me know. So I've got -s minus 1 equals 2 times the square root of 14 minus s. So I'm going to square both sides. So I get -s minus 1 times -s minus 1 equals 2 squared is 4 times 14 minus s. Last time I left it as 2 squared and then changed it into a 4 later. So on the left side of the equation, we have s squared plus s plus s plus 1, which is s squared plus 2s plus 1 on the left side. On the right side, we have what, 56 minus 4s. This is a second degree equation, so I'll move everything to the left. I'm going to subtract 56 and add 4s. So I get s squared plus 6s minus 55 equals 0. So factoring, let's see, 5 and 11, I'm going to have plus 11 and minus 5. So then S is going to be negative 11 and S is going to be positive 5. So the negative 11 would be the smaller value. The 5 would be the larger value. We're supposed to see if the solutions are extraneous and so indicate. So basically, we're going to check our work. Let's take the negative 11. S equals negative 11. That would give me negative times negative 11 minus 1 equals 2 times the square root of 14 minus negative 11, which would be 11 minus 1, or 10, equals 2 times the square root of 25, which is 2 times 5, 10 equals 10. So S equals negative 11 is not extraneous. In other words, it works. Okay. S equals 5, we'd have negative 5 minus 1 equals 2 times 14 minus 5. Negative 6 equals 2 times the square root of 9. Negative 6 equals 2 times 3. Negative 6 equals 6. So this one is extraneous. Okay, so negative 11 is correct. 5 does not work. Okay, that takes care of that person. Let's see here. Okay. Uh, 9.5. This is 9.5 number 16. It says solve the equation, enter your answers as a comma separated list. It says let f of x equal the square root of 2x squared plus, or excuse me, not plus, minus 2x squared minus 7x. And then it says for what value or values of x is f of x equal to 2. So we're going to put 2 in the place of f of x. So our equation is going to be the square root of 2x squared minus 7x equals 2. And I went ahead and flipped the equation around because I like to have my square root on the left. That's just me, the way I am. Square both sides, and we get 2x squared minus 7x equals 4. Subtract 4 from both sides, and we get 2x squared minus 7x minus 4 equals 0. Okay, so now we've got to factor this thing. I don't know what method of factoring the person that asked for did this, but I'm going to use grouping. So with that, I get A is 2, B is negative 7, and C is negative 4. So the product is negative 8 and the sum is negative 7. So how about negative 8 and 1? So then we get 2x squared minus 8x plus 1x minus 4 equals 0. Split it up, 2x times x minus 4, x minus 4 plus 1 equals 0. X minus 4 times 2x plus 1 equals 0. Maybe you're going, boy, I've forgotten how to do all this. That was back in the first chapter we studied. So if x minus 4 is 0, we add 4 to both sides and x equals 4. If 2x plus 1 is 0, 2x equals negative 1, subtracting negative 1, or subtracting 1 rather, x equals negative 1/2. And it says enter your, let's see here, for what values. So x equals 4, x equals 4 and negative 1/2. Okay. Let's see, that takes us to 26. Okay. And this is 9.5, number 26. It says let h of a equal the 4th root of a plus 12 minus the 4th root of 2a plus 3. Then it says find all values of a for which h of a equals 0. So once again, we're going to put 0 in the place of h of a. So our equation becomes 0 equals the 4th root of a plus 12 minus the 4th root of 2a plus 3. I'm going to add this term to both sides. So now our equation is the 4th root of 2a plus 3 equals the 4th root of a plus 12. I'm going to raise both sides to the 4th power. 2a plus 3 equals a plus 12. Okay. I'm going to subtract a from both sides. Oops. A plus 3 equals 12. Subtract 3 from both sides, a equals 9. If a solution is extraneous, so indicate, let's see if a equals 9 is correct. So I'm going to go back here and say 0 equals the 4th root of 9 plus 12 minus the 4th root of 2 times 9 plus 3. 0 equals the 4th root of 21 minus the 4th root of 21. Now, I don't know what the 4th root of 21 is, but it minus itself would be 0, so it checks. So this is not extraneous. All right. And now let's see here. Where did the mouse go? There you are. So chapter review. Come on. Things are moving slowly. And we want number 47. Okay. So this is the chapter review, number 47. And let's see here. I think I'm going to share what this one looks like so you get the idea. So here, so number 47, it says a corner of fabric is folded over to form a collar and stitched down as shown. All measurements are in inches. From the dimensions given in the figure, determine the exact number of inches of stitching that will be made. Simplify your answer completely, and then it says give an approximation correct to 1 decimal place. Okay, so from the dimensions given in the figure, determine the exact number of stitches that were made. So basically, we need to add the square root of 40, the square root of 32, and the square root of 8. Okay, so our problem becomes the square root of 40 plus the square root of 32 plus the square root of 8, and those are all inches. Okay, so let's go back here. And let's see here. 40 is 8 times 5, but 8 isn't a square. How about 4 times 10? So this would be 4 times 10, which would be 2 square roots of 10. This would be 16 times 2, which would be 4 square roots of 2. And this would be 4 times 2, which is 2 square roots of 2. Any question how I got those? These can be combined, so 2 square roots of 10 plus 6 square roots of 2 inches. So that's the correct exact answer. Now, we're supposed to get an approximation correct to 1 decimal place. So we've got 2 times the square root of 10 plus 6 times the square root of 2. I think I better put my glasses on here. I pushed the wrong button. Boy, I guess. Okay. 2 square roots of 10 plus 6 square roots of 2. I'm getting 14.8098, et cetera, et cetera. So to the nearest, to 1 decimal place, it would be 14.8 inches. So there's the first answer. There's the second answer. Okay. On to the next person. Okay, let's see here. Okay, let's see. Okay, this is the chapter review. Okay, so this is the chapter review, and we're going to look at number 6 and number 7, and let me pull those up. So the question that the student had was, why in problem number 6 do we not need absolute value bars, whereas in problem 7 we do need them? Okay, problem number 6, the directions say simplify the expression, assume that the variable is unrestricted, meaning the variable could be positive, negative, or 0. Use absolute value bars when necessary. Problem number 7, the exact same instructions. So again, the question was, why on number 6 do we not need absolute value bars, but on number 7 we do? Okay, the answer for 6 is 10a to the 6th power, because the variable is raised to an even power. Even if a was negative, a negative number raised to an even power would be positive. So there's no way that 10a to the 6th could be negative. Therefore, no absolute value bars are necessary. Now, on number 7, the answer, and they've got 4x inside absolute value bars, which is okay, or you could have the 4 outside. Why do we need absolute value bars there? Because just plain old x, not x squared or x to some even power, just plain old x could be negative. So we need absolute value bars around x to assure us that x isn't negative. Therefore, 4 times the absolute value of x is not a negative answer. Hopefully that makes sense. Okay, then the other question involved problem 38. And it had to do with parts A and B. So let's see here. It says substitute the x and y coordinates of each point labeled in the graph into the equation. The equation is x to the 2/3 power plus y to the 2/3 power equals 32. Which of the points satisfies the equation? And we've got, let's see, point A is negative 64, 64, and point B is 64, 64. Okay, so let's take a look at those. And come on, there we go. So we're going to put each of these points into the equation and see if they're true. So using point A, I would have negative 64 to the 2/3 power plus 64 to the 2/3 power equals 32. Now, 2/3 power, so you're squaring it and taking the cube root of it. And we can do those in either order as long as both of them are real. Cube root of a negative number is real. So I'm going to think of this as that and then squared, and this as that and then squared. The cube root the 1/3 power of negative 64 is negative 4, and that's squared, so we get 16. The cube root of 64 is 4, and that squared is also 16. 16 plus 16 equals 32. So point A is correct. All right. Any questions about that? Now let's go back and let's try point B. Point B would be 64 to the 2/3 power plus 64 to the 2/3 power equals 32. I'm going to do the root and then the square, the cube root, and then the square. So I'm going to get 4 squared plus 4 squared is 32. 16 plus 16 is 32. 32 equals 32. So both points are correct. And we've got one more student's questions. Let's see here. 47, 81. .5, number 16. Oops. Okay. So this is 9.5, number 16. It says, solve the equation, enter your answers as a comma-separated list. It says, let f of x equal the square root of the quantity 3x squared minus 11x for what value or values of x is f of x equal to 2. So again, we're going to take that 2 and put it in the place of f of x. So we get 2 equals the square root of 3x squared minus 11x. Okay. We're going to square both sides. So we get 4 equals 3x squared minus 11x. We'll subtract 4 from both sides. 0 equals 3x squared minus 11x minus 4. And let's use factoring by grouping. A is 3, B is negative 11, C is negative 4. The product is negative 12. The sum is negative 11. How about negative, let's see, negative 12 and 1. That would be a product of negative 12 and a sum of negative 11. So I'm going to take this equation and split it up. 0 equals 3x squared minus 12x plus x minus 4. 0 equals 3x times x minus 4 plus 1 times x minus 4. 0 equals x minus 4 times 3x plus 1. So x minus 4 equals 0. 3x plus 1 equals 0. Add 4 to both sides, and there you get x is 4. Subtract 1. 3x equals negative 1. Divide by 3. X equals negative 1/3. So x equals 4 comma negative 1/3. Okay. Do either of you folks have any other questions you'd like me to do? Or you've had enough? Okay, well, then I will stop the recording. And I'll be back at 1:15 if you have any other questions. And tomorrow, no class meeting, you just take your test.